Okay, this video is going to go over question 5 from the review exercises. Question 5, we have a kindergarten teacher who has a class of 13 students. 3 of the students are named Jack. The teacher writes each student's name on a ping pong ball, then puts the ping pong balls in a bag, and each morning the teacher pulls one of the ping pong balls out of the bag. The child whose name is on the selected ball gets to choose the song they sing at morning meeting. The teacher puts the selected ball back into the bag each day so that every morning he is randomly selecting one of the 13 balls. So the first question asks, if we let X equal the number of times that a student named Jack is selected in 5 school days, what is the distribution of X? Now, since the ball is replaced, the probability of a Jack being selected is the same every day because all 13 balls are always in there. And the probability of selecting a Jack is 3 out of 13. If we're mixing the balls and everything's sort of independent, which seems like a reasonable assumption, then we've got a fixed number of days, so 5 balls will be chosen. And so if we're looking at the number of Jacks, say, okay, well, that number of Jacks, X, is going to have a binomial distribution with n equal 5 and p equal 3 over 13. So if I want to know the probability that a student named Jack will be selected in at least 3 out of 5 school days, that's the probability that X is greater than or equal to 3. Which is, I can say, okay, it's the probability that X is equal to 3, plus the probability that X is equal to 4, plus the probability that X equals 5. Remember my probability mass function, f of X, is going to be 5 choose X, times P, 3 over 13, to the X power. 1 minus p, so 10 over 13 to the n minus x power, and that x can take values from 0 to 5. So I can substitute in here for x equals 3, 4, and 5, add them together, and I'm going to come out with 0.0843. If I let y be the number of days until the teacher randomly selects one of the students named Jack, I want to know the distribution of y. Remember that when I've got independent trials, right, and I've got the fixed probability of success each time, that the number of trials until I get my first success, and here I'm considering choosing a Jack to be a success, has a geometric distribution. And with geometric distribution, all I have to specify is p. Here, p is equal to 3 over 13. D, if I ask what's the expected number of days it will take until the teacher randomly selects one of the students named Jack. For a geometric distribution, the expected value, mean, is 1 over p. So that's 13 over 3, which gives us 4.3 days. Is my expected wait to pick a Jack. E asks us if instead of replacing the ball each day, the teacher decides to wait until all of the 13 children have been selected before putting them back in the bag. And now Z is going to be the number of times that a student named Jack will be selected in the first 5 school days. So when I'm sampling without replacement, I can't use a binomial anymore. I need to use a hypergeometric distribution. So Z is going to have a hypergeometric distribution because I'm sampling without replacement. Remember, when we're working with a hypergeometric, we have capital N is the total number in the population, so there's 13. N1 is the number in category 1, so that would be the number of jacks here, it's 3. N2 is the number in the other category, so that would be the 10 non-jacks. And we also have to specify the number that we're going to choose. Here we've got 5 days, so we'll end up choosing 5 students. And so our distribution function, f of z, is going to be n1, which is 3, choose z. N2, 10, choose our n minus z, divided by our capital N, which is 13, choose n, and z can take values 0, 1, 2, or 3 in this situation, because I obviously can't choose more than 3 jacks when there are only 3 jacks. And the last part, part F, asks us what is the probability that all 3 students named Jack will be selected in the first 5 days. So that's looking for the probability that z is equal to 3, which is f of 3. So I'd have 3, choose 3, times 10, choose 2, divided by 13, choose 5, which will give me a probability of, rounded, 0.0350. And that is question 5.